This is video 3 of Unit 8, and we're going to be solving quadratic trig equations. Now, the trick to this, first of all, is to realize that you already know how to do all this. It's just an application of solving quadratics that we've done so much of this year. So do not get afraid that you're doing anything that's fantastically new. You already know how to do this. It's just that we're putting two ideas into one. The first thing I'm going to discuss with you is this notation. Now, if you notice that in the past, we've usually written sine x squared with parentheses and a square. But because that's a lot of work, we like to use this version where we put the square right next to the sine and then the x. These two things mean the exact same thing. It's the shortcut that mathematicians use so that we don't have to use parentheses. So let's look at this first one. It says, consider the trig equation sin x squared minus 4x minus 5 equals 0 on the interval 0 less than x less than 360. And when we do such a thing, what we need to do is we're going to factor the left side of this equation. Now, the thing that we are using to factor is not x, but rather sine of x. So we have to think about this as being 1 sin x squared minus 4 sin x minus 5. So what two numbers multiply to -5 and add to -4? It's quadratic. So we're going to do sine x. So this is really 1 sine x minus 5 and sine x plus 1. And this is still an equation, so we still need to make sure we have an equal sign and it equals 0. Now it says use the zero product law, in other words, that's t time, to write two linear equations whose solution comprise the solution of the set of the quadratic trig equations. I'm going to type this because it'll go faster for me. So we have the sine of x minus 5 is equal to 0. And we have the sine of x plus 1 is equal to 0. So now you're going to solve each equation, state the solution set of the trig equation. So the first thing we have is sine of x minus 5 equals 0. We're going to add 5 to both sides, just like we would when we solve the problems. And then we get, on this problem, sine of x is equal to 5. Now stop and think for a minute. What value of x gives you a sine value equal to 5? And there's no solution because 5 is actually bigger than 1, as you all know, and sine cannot be bigger than 1. But what about the other side of the equation? Well, over here we have that sine x plus 1 equals 0. We're then going to subtract 1 from both sides. And we get that sine of x is equal to -1. So using all of your knowledge of everything that we've worked on this year, where is sine equal to -1? And that's over here on the x-axis. And so that is when x is 180 degrees. So the only value that's going to solve our equation is 180 degrees. We're going to continue that, and we're going to factor. That's always the biggest idea. Now, if you personally are having trouble factoring these, come see me. I will show you an alternate method individually about how to factor that may be easier for some of you. It won't be easier for all of you, but some of you have a harder time factoring than others. So if you look at this equation, 2 cosine x minus sine or times sine x minus cosine x equals 0. You know that we have multiplication. You see cosine of x written twice. What that means is that we're going to factor it out, that we have the cosine of x is a factor, and then we're left with 2 sine x minus 1 equals 0. And we're going to be on this interval, so all the answers between 0 and 360. Well, that means that we're going to do a little bit of t time work. And on the left side of the t time, we're going to have, where does cosine of x equal 0? Well, going back here, cosine of x is 0 on the y-axis. So that means when x is 90 degrees and when x equals 270 degrees. So there are two locations right there. There are two answers so far that we have for this problem. Oops, did I make a mistake? I think I made a mistake back here. Oh goodness, sine of x is -1, y is -1, not at 180, but at 270 degrees. I apologize. It's where y is 1, not x is 1. Sorry to go back and correct that, but that's where my mistake was. Here, down here, we have 2 sine x minus 1 equals 0. We're going to add 1 to both sides. And then you get, my phone is ringing. That never happens at my house. Hold on, Paul. Okay, sorry about that. So now we get, I don't want to delete my recording. Sine x is equal to 1/2. So where is sine of x equal to 1/2? So that would be, where is sine equal to 1/2? And that's when x is 30 degrees, is the reference angle. And so then we have to think about what quadrants. We have quadrants 1 and 2. So that means that sine would equal, or x would equal 30 degrees. And quadrant 2 is going to be 180 minus 30. So that would be at 150 degrees. So this question has 4 answers. We have x equals 90. We have x equals 270. We have x equals to 30. And we have x equals to 150 degrees. Okay, moving on to the next question. We are going to factor this. This one factors slightly different. This one is going to factor using the square root method. So you have 16 cosine, I'm going to use the caret here, cosine squared of theta minus 1 equals 0. What I'm going to do here is I'm going to add 1 to both sides, equals 1, and then I'm going to divide by 16. So I get cosine squared theta is equal to 1/16. The next step that we're going to do is we're going to take the square root, and we're going to do that on both sides. So now we have the cosine of theta is equal to plus or minus 1/4. So at this time, you need to figure out inverse cosine of your 1/4. So you get that on your calculator. And then we have to think about which quadrants would we be in if you are at plus or minus. Well, this means that we're going to have 4 answers. We're going to have a quadrant 1 answer, quadrant 2 answer, quadrant 3 answer, and a quadrant 4 answer. So there'll be an answer for this in all 4 quadrants. I will get that answer for you shortly. You can pause now and check it. I'm going to do the same thing. Okay, so here are the answers you get. For quadrant 1, you get 75.5. Quadrant 2 is 104.5. Quadrant 3 is 255.5. And quadrant 4 is 284.5. The last question that I'm going to join the video, I'll leave you to think about the other one on your own. The bottom one is going to be done by the difference of perfect squares, is we're going to do this one. Now, remember that you are going to be dealing with a quadratic that is not easily factorable. You've got this 3 in the front and 8 here, and now it's a quadratic. So this is kind of like x squared. So think of sine as being x. And if you recall, to do that, you've got to come up with the 2 numbers that multiply to give you, or we multiply a times c, we get 24. So you need 2 numbers that multiply to give you 24, but add up to 14. And hopefully, as I was writing that, you were thinking of the numbers 2 times 12. So this is the split the middle. So we have, I'm going to leave off the theta for right now. We have 3 sine squared plus 2 sine I'm going to use x. It'll be easier for me, guys, okay? 2 sine x plus 12 sine x plus 8. And now on the next line, we have to factor out what they have in common. So the first set of factors has the sine x in common. Then we're left with 3 sine x plus 1, or plus 2, sorry. And then the other one, they have a 4 in common, and then you're left with 3 sine x plus 2 equal to 0. And then in the next thing, the next line, you're going to factor out the greatest common factor of that, which is the 3 sine x plus 2. And the other factor is sine of x plus 4 equal to 0. After that, time for some good old tea time. And we're going to solve both sides of the equation. On the left, you get 3 sine x plus 2 equals 0. Subtract 2 from both sides. So then you get 3 sine x equals negative 2. Divide both sides by 3. So that you are left with sine of x is equal to negative 2/3, and you solve that using the reference angles. Over here you have sine of x plus 4 equal to 0. Subtract 4 from both sides. You get sine of x is equal to negative 4. This is not possible. Sine must be less than 1. Must be between negative 1 and 1. In this case, it's not. I'm going to pause, and then I'm going to put up the answer to solving this piece and give you all the answers for this section. Okay, so the answer to this, you got the reference angle is 41.8. So then we have to find the answer in quadrant 3 by adding 180. So we get 221.8. And the answer in quadrant 4 by subtracting from 360, you get 308.2. So these two answers are the answer to the question. And finally, the last question. When you solve this, you have 2 sine squared x minus 1 equals 0. You add 1 to both sides. Then you divide by 2. You get sine squared x equals 1/2. You take the square root, and when you rationalize this, and don't forget the plus or minus, you get square root of 2 over 2. When you have plus or minus, that means you have an answer in all 4 quadrants. And if you recognize square root of 2 over 2, which you showed, it's from your 45, 45, 90 triangle. So in quadrant 1, it's 45. Quadrant 2, it's 135. Quadrant 3 is 225. And quadrant 4, it's 315. This concludes video 3. Tomorrow's topic will be Pythagorean identities, and we'll continue on besides that and do the sum and difference. So tomorrow you will have to watch 2 videos.